Hi, I thought I'd come and sit next to my telescope for this video since it's actually potentially an important video in the series of Expanse Tension Theory development. Most of you hopefully will have seen that Expanse Tension Theory proposes a modulation function which couples mass to expansion of the universe. It can couple and uncouple depending on the environment density or the rest mass density, which also gives us the measure of weight. Now that function, it was in the first paper proposed, looks something like that, and it suggested something quite important. It said on a continuous function from coupling to uncoupling of mass to expansion, in extreme density environments where there's uncoupling and mass is resisting expansion, as density builds up from stellar formation to neutron stars, then black holes just exist on the end of a continuous function. And now I've spent a lot more time looking at what that means for black holes. They don't require mathematical singularities. This is just an extreme gradient strength in the Holland field because mass is extreme resistance to expansion of the universe. And that models mathematically to describe what black holes can be, which I think could be fantastic for the world in an understanding something where previous singularities and infinities destroy our ability to look any further. But this video is about the other end of the scale, because if the universe is balanced and elegant and beautiful, and at one end of this extreme density coupling function we have something as violent as a black hole that would crush us and freeze time, bend light to the point where it can't escape, having passed the event horizon, well, what happens at the other end? So I've spent a lot of time now looking into this as a possibility and researching into it. And my finding is there could be something as dramatic at the other end of low density. Now at the moment I've called it a bright void because that describes its nature. It is a vast void of nothingness. There's no density there. Density is so low. But in that regime, coupling to expansion is absolutely rock solid. Every single particle of dust is coupled so tightly to expansion that the universe in those phases just run open and free. Light can potentially run so free and unhindered and unobstructed that there's even a potential that light could exceed current finite limits, which would be an incredible discovery if we could see that light can run through bright voids faster than our current assumed speed of light. So passing into a bright void would mean passing what I call the expanse horizon, the opposite, equal, inverse of a black hole. And this, as a bright void, is an opposite inverse of a black hole. If there's an expanse horizon, you pass into it, your matter becomes so tightly coupled to expansion, you are effectively spread over vast empty spaces of nothingness, and that expansion takes your particles of mass with them. But where time freezes in a black hole, in this, time dilates to almost, I don't want to say an infinity, but time kind of dilates to huge values. So, you know, an 80-year life could be spent over 8 billion years inside a bright void. So this announcement is about this idea that there is an equal, opposite, inverse to a black hole in the universe. That was one of the thought that a bright void could do. As from the Big Bang, we're going through expansion. Of course, the universe is getting less dense. Eventually, there will be a dominance of voids and a dominance ultimately of bright voids and passing over this expanse horizon. Now, that could then mean the breakdown of what is a fabric of expansion for the universe, and I've described as a Holland field of expansion. That could ultimately break down, meaning that any residual matter or mass in the universe then can take over, which could then create the bounce and create the big crunch and reverse the universe from its expansion mode back to contraction mode, and then we end back up at the Big Bang. And it's the bright void dominance that could allow that to happen. So, video to introduce bright voids, and if you fall into one, you'll be passing over an expanse horizon, and I think it sounds beautiful. It's bright, lights running free, and it's a bright void. And hypothetically and theoretically, expanse tension theory predicts they exist. And again, the upside is it gives us a lot of potential predictive ability to think about universal cycling bounce back to Big Bang models. Anyway, thank you very much. Thank you for listening.